there guys, and welcome back. On this week's show, we're going to be doing a tutorial for rabbeted drawer fronts with half-blind dovetails on the Lee D4R Pro dovetail jig. On my channel, I've posted a couple of videos on the D4R Pro jig with through dovetails, etc. And today, as I've said in the past, I want to get more tutorials on the channel, and today we're going to be doing those rabbeted drawer fronts. So we're going to get right into it with choosing the router bit that you need to make these dovetail joints. Well, with half-blind dovetails with the Lee jig, you really need to decide what your pin board thickness is going to be. And depending on how thick your pin board is, it really governs what bit you use. There is very specific bits that you can use and very specific depths that you can cut the dovetails. So I'm going to use a 1/2 inch thick pin board. For the front face, they will be 3/4 of a face, but they will be rabbeted to 1/2 inch thick pin board. Now on the pin board on the front face, you only require 1/16 of an inch of material left over once you route your pins. But they are recommending with the Lee jig that you leave 1/8 for the material that's left over for the pins. Now, I'm going to try to go with 1/16 because I don't want different size pin boards. So if you look at this chart here, you can see depending how you want to go, if you want to leave 1/8, for a 1/2 inch, if you 3/8 plus your 1/8 that would be left over, this would be a 1/2 inch board, and you could use this 1/28/8. This is an 18-degree dovetail bit with a 3/8 depth cut. Now I'm going to be using a 120-8 or the 120 bit, which is a 14-degree, which will go 7/16 of an inch deep. It's a 14-degree bit, and that will leave me 1/16 of material. If you have the D4R Pro, you already have this chart in your manual, and you really need to check it to be aware of what bit you need. So for me, for this particular purpose, I'm going to be using 1/2 inch thick pin boards, and I will be trying to use the 120 bit, which is a 14-degree with a 7/16 depth cut. Well, before we get too far into using the actual jig and doing the dovetails, you want to do some prep on your stock. So here I have pieces of my drawer. I have the rear pin board, and I have my 2 tail boards for the sides, and I have my 3/4 inch thick face, which will be rabbeted. Now I'm going to want a profile on this drawer front, and I find that it's much easier with a small drawer like this to route that profile first. Because once you rabbet this edge, if you're using a bearing guided bit, depending on how deep your rabbet is and how thick your lip is here, you may not be able to run that bearing on enough surface to get a good edge. So I'm going to route a 1/8 inch roundover on all the outside edges of all of my drawer faces for the drawers that I'm making. And I've just taken my trim router, placed it in my front vise of my bench, and it basically becomes a router table, essentially. I prefer to use it like this on small parts, keep both hands free, don't have to hold the router. It's just a little safer for me as long as it's securely clamped in there, and it is. So let's route all those front faces, at least the profile of it. Well, now that you have your profile routed on the front face of your face plate, I guess we'll call it, You're going to need to route the rabbet, and for that we're going to use the router table. Now, as long as the edges of your rabbet are not more than 3/8 by 3/8 of an inch thick, in other words, that lip, you're fine with the lead jig without any modifications to it. However, there are instructions in the manual for if you have a larger lip than 3/8 of an inch thick by 3/8 deep from the outside edge. Mine are going to be 1/8 of an inch deep, and the actual rabbet, or the overhang, or the thickness of it, is going to be 1/4 of an inch. So I'm fine and well within the guidelines of the jig. So let's head to the router table and I'll show you how we're going to route these. Now I have the router table set up. I have a 5/8 of an inch diameter straight bit installed, and I've put an MDF sacrificial fence here. And the reason I've put that fence is because some of the drawer faces are rather small, and I didn't want to be bridging that gap across the original fence to have it dip in and screw up my routing. It's just a little more support and a little more secure way to be able to route these rabbets. So what I have is a scrap piece of stock of the exact same thickness as the drawer faces that I'm using, and I'm going to do a couple passes here just to test how my depth is. We want to end up so that the inside face of the material that's left once it's rabbeted is the exact same dimension, exact same size as our pin board at the back of the drawer. So there's several adjustments that need to be made, but either way, let's route this test board and see how we make out. Well, I've made adjustments to the bit. I've ended up making about 3 or 4 passes. I have a 1/4 inch lip there now at left over on the sides, which I'm happy about, and my depth is correct in order to make our piece the same size inside. I've done that through a few calculations, and again, you'll have to do your own depending on the size drawer that you're going to need. But now that I'm happy with the setup, I can carry on and route all of the rabbets in our oak drawer faces. You're also going to need a spacer for the routing process due to the rabbet, and it needs to be the exact same depth of a cut on this spacer as what you've done on the drawer faces. So the easiest way is just cut this spacer and make sure you do the rabbet at the same time that you're at the router table with all the rabbets for the drawer faces. Well, now that you've got your spacer routed and all of the rabbets routed for your drawer faces, it's time to come over and start setting up the jig. And if you already own this particular jig, you know that you need a spacer bar or a spacer board for some operations. So we're going to place that spacer board in place there on the top bed of the jig and just clamp it into place. Now that you have that done, we can move on to setting up the fingers. So to get started with the setup, you want to mount your finger assembly in the half-blind tails mode. And I'll just pan off me here and show you a picture of what that looks like. And there it is right there. And once you get it in that configuration, you want to set your scale on the sides for the thickness of your pin board. So for us, our pin boards are 1/2 inch thick. So we are going to set our scale here and on the opposite side at 1/2 inch. You now want to mark a line on your tail board with the working depth of your drill or of your router bit. And if you remember from our bit selection from earlier, the working depth was 7/16 of an inch. So here I've marked a line from the edge of our board down 7/16. We're now going to mark all of our tail boards with this symbol here on the inside face. And we're going to mark all of our pin boards with this symbol on the outside face. So the only purpose for those markings is to keep your alignment in check so that you know what you're routing. And in this case, this is the inside face of our drawer, so we know that that needs to be, in this case, facing out. So we have our spacer board in, we have our finger assembly resting flat and flush onto our spacer board and tightened down, and we now need to take our board with the inside face, this is our tail board, our inside face facing out, and we're going to clamp it right into the front, tight up against our edge stop here and tight up against the lower edge of our fingers. Now we've raised the finger joint assembly or the finger assembly just above that spacer to allow us some room to move these fingers here for our layout. So we're going to ignore the first guide finger here. This outside guide finger is just for router support. It really has no other purpose here. So we're going to loosen these off, slide them out of our way, and once we get them out of the way, we want enough of them here that we're going to be able to set up the routing on our small little drawer here, and it is rather small drawer. So we'll just evenly space some of these fingers, and that one there wasn't loosened enough. There we go. So we're just going to evenly space them there as best we can, and once we're happy with that setup, we're going to tighten them down, and then we'll bring these ones back in and tighten them up over here just for some more router support. You don't need to crank these down, guys. Just a little tighten is all they need. They'll hold really securely in place just with a little snug. Now the active routing surfaces on these fingers are the outside edges, and if for some reason you have a finger that is wider or you want a wider tail, you can put a spacer in between here. They provide you with a, it's actually a plastic extrusion that goes in here, and you just cut it to your width and it slips in there. It works quite well for keeping your router out of there and routing this properly. But for now, this is the setup I'm going to go with, and we can move on to the next step. We're now going to set the depth of the bit so that the cutter is in line with the center of that line that we drew earlier. And once you get it lined up, just give the bit a spin to make sure that nothing is obstructing it. Now that we have that done, our first pass on these tail boards, we're going to want to start from right to left, and we're basically climb routing here. Get a good grip on your router, and you just want to have the tip of it cut across to clean your edge. Once you get that done, you're going to go in and out between the fingers going from left to right, and that will clean out all the other areas for your tails on these boards.
And there we have one tailboard cut. You may notice that I did the first cut across here just to give us a sharp edge here with no tear out. Then I went left to right, and then just to clean it up to make sure I didn't miss anything, I went right to left. That last pass you don't have to do, it's just something that I like to do. So that first routing is nothing more than for setup. Don't route all of your tails yet, just the one for setup. And we're going to take a piece of scrap. We've clamped it here in the front so that it acts as a stop block. You can see that there, that it stops this one from going any further. And then we're going to clamp this one down so that it's tight against our stop at the side and tight against our scrap stop block in the front. And with that there now in place, we're going to rotate our finger assembly here around to the half blind pins mode. And again, we're going to set it for the thickness of our pin board stock. The scale when doing half blind dovetails on this jig is always set to the pin board thickness. That setting never changes. So just set that and you'll be able to get your pins routed here, or your test pin board routed. The thing that makes the joint fit on a half blind is not actually the depth of this particular cut, it is the depth of your router bit. So in this case now, we have this set up. We're going to lower our assembly down onto our test board and we're going to route them and see how our fit is. So at this point now that we have this set in with our test board, we're checked to make sure that everything is aligned and everything is flush against the stop guides on the left side here. We're going to route in between the spaces of our fingers. And we want to route, if it's larger spaces or variable space dovetails, you want to route from left to right here. Don't go right to left. So let's route these spaces. Well, we're just going to check the fit of this joint, and wow, I have to say I'm shocked. I usually don't get it first try. There's usually an adjustment here to be made, so I managed to get this in one shot. So now that I've gone and done that, let me explain the adjustments to you should your fit be too loose or too tight. Okay. I've never had one be right on first shot, so of course it's when I was filming and I was hoping to show you how to adjust it now because it was too loose or too tight, but it didn't happen. Lucky me. Anyway, if your joint is too loose, that means that your pins and your tails, they're too sloppy in the fit. You basically want to pull the joint apart and measure the gap between the bottom of the tails and the socket for them in the pin board. That distance is how much you want to lower your router bit. If your joint is too tight and you can't get it together, then you want to raise your bit ever so slightly, try again, and then see how it goes. Bottom line is, too loose, lower the bit. Too tight, raise the bit. Well, now that you're finished doing test fits, it's time to route the real McCoy. And for that, we're going to route our tailboards first. And you want to keep the inside face of your tailboards away from the jig. So turn that finger assembly into the half-blind tails mode and line up your pieces against the left stop fence and route all the tails for all your drawers. So now that you've got all of your tails routed, it's time to route your pins. So for these little drawers, start off with the pins or the pin boards for the back of the drawers. Don't worry about your rabbet for now. We're going to route all of the back boards. On your first drawer, just test your fit to make sure that's going together. And once you finish routing those pin boards, then we're going to do the rabbeted joint. Just don't forget, guys, to flip your finger assembly forward into the half-blind pin mode. Just remember, guys, when routing the pin boards, the inside face is away from the jig body. Well, now that you've got the pin board for the rear of the drawer mounted, it's time to do the rabbeted front. And as I said earlier in the show, as long as your thickness here and your depth is no more than 3/8 by 3/8, it still fits in the stop blocks underneath because it actually has an overhang that allows for that. The difference is you have to allow for the depth of your cut on your pin boards to be different, hence our spacer board. So you can see here that we have our spacer board in place, clamped in the front, like what we did with the spacer board initially so that we know where to stop this. We're going to bring our rabbeted board in like this with the inside face of it away from the jig or facing up against our stop guides on the left and up against the inside edge of our spacer. Can you see that there? And once you get that in place, clamp it down and then lower your pin board or your fingerboard assembly rather in the pins mode down onto your rabbeted face and route just as you did the other pin boards. So let's get that routed and then we can test our first completed drawer. that Rabbeted front now joined together, we can do a test fit here and just see how everything fits together. Hopefully everything fits just fine. I don't see why it wouldn't, as we did our test piece earlier. So we just check for alignment as we go and make sure that everything is hunky-dory, so to speak. Just like that. And just like that. And there we have it, our Rabbeted half-blind dovetail for our drawer. Now all that's left to do here, of course, is I need to put a slot on the inside for our drawer bottom. But that's not what this video is about. This video is about the half-blind Rabbeted dovetail joint with the lead jig. Before I conclude this video, I really just want to clarify that spacer because I actually made a mistake on it. When you route the spacer for the rabbet, I said that it is equal to the depth of your rabbet, and it is. Just don't route it so that it's equal to the bit height. That is not the depth of your rabbet in this case. It's actually the distance from the back of the fence to the front of the cutter. So just remember, it is this distance right here from the edge of the drawer out to the outside edge of this rabbet. That is the distance of the offset of your spacer. And there you have it. Rabbeted half-blind dovetails, done with the D4R Pro dovetail jig. And you know, guys, this isn't a difficult process. It's all a matter of a couple test fits. I fluked it on this one today, but a couple test fits using one dovetail bit, proper bit selection according to the manual for depth of cut, and then just careful preparation on your stock to be able to carry on and get all of these done and done properly. It's not a hard process. There is more to it if your joints carry things like thicker rabbets. If the leftover lip is thicker than 3/8 or wider than 3/8, it does change things up a bit, but that's perfectly explained in the manual. I will also say that this particular video will also work for half-blind dovetails without the lip. You just don't need that spacer to route the front edge of, or the front faceplate of the drawer. It's the exact same process for setup, for bit height, to do your tails, your pins. Everything is identical for the half-blind. The only difference for this is, of course, the spacer. So guys, I want to thank you for tuning in this week. I hope you've enjoyed it. And for any of you out there that have been a little confused on how to do these with the jig, I hope it's cleared up any questions. If not, drop a question down in the comments below and I'd be more than happy to help you out. Thanks for watching, guys, and I'm going to see you again next week with yet another woodworking video.